Okay, so this is more of a word problem, but it's still a dosage calculation problem. We have the following. A 10-pound cat has ingested Tylenol, and the antidote is acetylcysteine, available in a 10% concentration. If the initial dose is 140 milligrams per kilogram, and follow-up doses are 20 milligrams per kilogram, PO, which is of course by mouth, Q4H, which is every 4 hours for 3 days, what is the total number of milliliters of acetylcysteine needed? Say that 10 times fast. Okay, so what we need to do is figure out the initial dose, how many milliliters of the initial dose, and then how many milliliters total of all the follow-up doses. Add up all of that information, and then we will be good to go. So we need the initial dose. Let's try that again. Make this a little bit easier to see. So there we go. So initial dose, and that's going to be in milliliters, plus follow-up doses, which will also be in milliliters, is going to be the total amount needed. And the basic information that we have is as follows. We know the weight of the patient. Oops. There we go. We know the weight of the patient is 10 pounds. We know the concentration of the drug is 10%. And we have the dose information for both the initial dose and also the follow-up doses. So there's our initial dose, and those are our follow-up doses. So what we want to do is first figure out the initial dose. So again, the weight of the patient, 10 pounds. The dose is going to be 140 milligrams per kilogram. And the supply, or the concentration, is 10%. And that's 100 milligrams per mil. So for the initial dose, this is a straightforward dosage calculation problem. What we want to do is start with the weight of the patient, which is 10 pounds. Change it from pounds to kilograms, because we are giving 140 milligrams per kilogram, so we want to be out of pounds and in kilograms. And then we want to multiply by the dose, which is 140 milligrams per kilogram. So that'll get us out of kilograms and into milligrams. And last but not least, we want to change milligrams into milliliters. So that's going to be 1 milliliter contains 100 milligrams of the drug. So that's out of milligrams and into milliliters. So then if we do the math here, the factors left in the numerator are 10 and 140. 140. And the denominator is 2.2 and 100. And that's milliliters. So we have in the numerator 1400. And in the denominator, we have 220. That's milliliters. So when we do the math here, just check. 1400 in the numerator, 220 in the denominator. 1400 divided by 220 is 6.3636, etc., etc., etc. So let's call this 6.4 mLs. And we're going to need to remember that because that will be part of our final answer. Okay, so that gets us, the initial dose will be 6.4 milliliters. Now what we want to do is go to the follow-up doses. So for the follow-up doses, we're going to need to change a couple of things. Let's go to the next page. So for the follow-up doses, again, the weight of the patient is still 10 pounds. The follow-up dose information, however, has the dose given at 20 milligrams per kilogram, and we still have a 10% concentration. Right, so that's still 100 milligrams per mil. We also need to figure out how many doses, follow-up doses, we have. So we're supposed to be giving these Q4H for 3 days. Now Q4H every 4 hours in a 24-hour period, that is going to be 6 times per day. So 6 times in 1 day. And since we're doing this for 3 days total, that's going to be 18 doses. So 6 doses in 1 day for 3 days is going to be a total of 18 doses. So whatever we're going to get for a follow-up dose, we're going to have to multiply by 18. So let's go do the math here. So for the follow-up dose, again, we have the 10 pounds. Let's make this a little smaller. We know 1 kilogram is 2.2 pounds. That gets us out of pounds and into kilograms. We're giving 20 milligrams for every 1 kilogram, which gets us out of kilograms and into milligrams. And we know it's 1 milliliter contains 100 milligrams of the drug. So that's what this looks like for a single follow-up dose. So in my numerator, I have 10 times 20. In my denominator, I have 2.2 times 100. So this gives me 200, and this gives me 220. And that, of course, is going to be in milliliters. So when we do the math here, 200 divided by 220 gives 0.9090 milliliters. So you can round this to just 0.9 and then multiply by the 18, or you can multiply by the 18 and round at the end. If we just round now and do 0.9 mLs times 18, that would give us 16.2 mLs. If we were to take the original value, the 0.909090, et cetera, et cetera, et cetera, et cetera, multiply that by 18, it comes out closer to about 16.4 mLs. So there's a slight difference, but essentially a single dose, since you're going to be giving a single dose, you want to know what the value of the single dose is, and that would be 0.9 mLs. So we're going to go with this as the additional amount. So now what we need to do is come up with the full amount of acetylcysteine. So if we go back 1 page, we have 6.4 mLs from our initial dose, right? That's our initial dose. So down here on the left, we have 6.4 from the initial dose. We have 16.2 from all the follow-up doses. So if you add those two together, you get 22.6 mLs total. So that would be the total amount of acetylcysteine that you will need to give to this PET. 6.4 to start, and then 0.9 mLs 6 times a day for 3 days. So the total amount is 22.6.